Right, this is the Mastery Solution video for numbers 4 and 5, synthetic division and long division. So this should be pretty new for you guys since we just finished up that unit today. So if we look at that first example for synthetic division 4, the first thing we need to do is set our binomial equal to 0 and solve to find the 0 number that we use for synthetic division. The next thing we check for, do our exponents decrease in order and do we need any placeholders? In this case, it goes x3, x2, x1, and our constants, so we cover all our variables and it's in decreasing order, so we can write our coefficients as we see them. So go ahead and drop down our first term, multiply diagonally, and add vertically. Multiply diagonally, add vertically. Multiply diagonally one more time and add vertically. So in this case we do get a remainder. So when we write our final answer, our degree that we started with was x to the third power. So then our remaining polynomial is going to start with the x squared. So we've got 3x squared plus 7x plus 24, and then we write our remainder over what we're dividing by, which is 68 over x minus 3. Let's look at our second example. So our binomial is a plus 2, so we set that equal to 0 and solve, so our 0 number is negative 2. Now I underlined a to the third power because that should be our leading coefficient. So not only is this polynomial out of order, doesn't go in decreasing order, but it's also missing the a squared term. So we do have to write them. A to the third term is first. We have a 0 for a placeholder for a squared. Our a term is negative 1 for a coefficient, and then the constant is 6. So we'll run through our synthetic division process, multiplying diagonally and adding vertically. This time we do not get a remainder, so that means a plus 2 was a factor. And once again, our highest exponent was a to the third power, so we start with a squared. Let's go to the long division problems. So we set it up just in our regular long division format, the binomial on the left, the polynomial underneath the division bar. And then we ask ourselves, 3x times what is 3x to the third power? I need an x to the squared. I multiply x squared times both my terms in my binomial and write those underneath. Regular long division algorithm, we need to subtract. And be careful because we're subtracting, not adding. So negative 5 minus positive 1 will give us negative 6x squared. Bring down that next term. 3x times what will give me negative 6x squared? I need a negative as well as a 2x. Multiply. Then we're going to subtract. 10 minus negative 2 is the same as 10 plus 2. Again, we have to really be careful here. So we get 12x, bring down that last term. 3x times what is 12x? We're going to get a positive 4, and then multiply by 3x and 1. We end up with a remainder of negative 7, so we write it the same as we did for synthetic division by putting it over what we're dividing by. Okay, let's look at example number 2. So again, set it up the same way as the first one, but this time we do have a placeholder for the linear term, so we need a plus 0x underneath the fraction bar. So ask ourselves, 2x times what is 2x to the third? And then multiply that number, x squared, by 2x and negative 5. Write that underneath and subtract. Negative 9 minus negative 5 is the same as negative 9 plus 5. So we end up with negative 4x squared, and we're bringing down that 0x. 2x times what gives us negative 4x squared? Negative 2x, and multiply by 2x and negative 5. Subtract. Bring down the next term, and the last time we have to do this. 2x times negative 5 gives us negative 10x squared, and when we subtract we get a remainder of negative 10. So we write that remainder over what we're dividing by.